Hello friends, so today we're gonna be solving this problem from LeetCode, that is validate binary search string. So what do we mean by validating? So validating simply means that you want to know that something is correct. Okay, so here we want to validate a binary search tree, which means that we will be given a tree and we want to know whether the tree is a binary search tree or not. If it is, then return a true, otherwise return a false. So let's take some example to better understand this question. So I have taken some binary trees here. So the first one is 53614. So is it a binary search tree? So what are the three basic conditions for a tree to be a binary search tree? So the very first condition is the left subtree of a node containing an of a node contains only nodes with key less than the node's key. Any key, this node. Let's say we have this node. So all those nodes which are on the left side of it has to have a value lesser than this node's value. That is fine. So all of those nodes like 5, 3, 3, 1, 4. These are the values of the nodes that are on the left side of one, which are lesser. So it satisfies the condition. So 5. So we have 6, which is obviously greater than 5. It can't even be equal to. Even if there would be 5 here, we would have said that it is not a binary search tree, but because it is not the condition, that this is a binary search tree. So similarly, let's check for this one as well. 5, 1, 4, 2, 3. Okay, so 1. So on the left side has to be, on the left side the values must be lesser than. On the right side, the values must be greater than. And also the left subtree and right subtree has to be binary search tree, in themselves. So this is how it becomes. Okay, so how can we do this solution? Like, what are the possible ways? Obviously, we're gonna be using recursion because it is belonging to binary search tree, and we have to validate for subtrees as well. So we're gonna be using the concept of recursion. But how will we be doing it? Like, what is going to be the brute force solution? If you say, like, if you remember, binary search tree have a property that the in order of BST is sorted. So what we can do is we can iterate. We can try to find the in order. Find in order. And that will take around open time complexity. And if you are using a stack, then it will be open. Space complexity will be open and time complexity will also be open. So how will we do it? Like, let's say, let me write the in-order traversal for this one. So for this one, the in-order traversal will be 5. Sorry, not 5. It will be 1, 3, 4, 5, 6. And for the second one, it will be 1, 5, 2, 4, 3. So once I've got the in order, I can simply traverse in orders and figure out whether the sequence that we have found is sorted or not. If sorted, then I return a true. If not sorted, then I can return a false. So here, let me check, like 1, 3, 4, 5, 6. Yes, it is sorted. So what I can return is true. Now, for the second case, we have 1, 5, 2, 4, 3, which is not sorted. So I'm going to be returning a once. Simple, as simple as it. Okay, so you know how to find the in-order traversals. I will not be spending too much time into it. And it will be a one solution. You can either use the recursive approach or the iterative approach to find the in-order. Both of them will be taking open space with open time complexity, so there is not too much of a difference, but I prefer using iterative. You know how to do it. If you don't know how to do it, you can check out the iterative solution of in-order traversal on internet. It's very useful. You must be knowing it. And so this is the solution on the time complexity problem is part and state complexity is 1. So let us find a better one. Let's try to find a better solution. So obviously, all fun space is getting utilized, and that is something what you don't want. What can be the alternative solution? So, what can be an alternative solution? No, here the time complex, here the space complexity was all fun plus overcome. Because all fun for ASS. And also ASS for in order storing the in order. At bare minimum, you can convert into one by not storing the in order, but just comparing it with the previous value that appeared. Okay, so you won't have the need to store them individually, right? Okay. Now method number second. In this method, we are using recursion. So there has to be a front auxiliary space stick slash text space. Sorry for that. Complexity is off again. So you will be saying how are we improving on this then? So we are not improving, being honest. But I just want to tell you another approach which can be applied here. So this simply says that let me just copy down this thing and paste it here. Okay. Sorry, ये क्या कर दिया? Okay. So, like we know that for BST concept, this is our concept. For BST, nodes on left are smaller than root. Nodes on right are greater than root. Here's the interest. This thing. Here's this thing. Okay. So how are we going to do this? It is very, very simple. Very, very simple. Extremely simple. You will understand it in just one go. So what I'll do is I initially have my root here at 5. Okay. So let me just call a function with 5 and a minimum value. Let's say for the initially we will have a minimum equal to minus infinity and a maximum equal to infinity. So I want to check in this function after I will be checking whether the value of 5, whether the root value, this simply represents the root. Okay. So whether the root's value is in between min max or not. If it is, then you must be calling then you must be calling its left and right, then must be calling the function for its left and right subset. So in our case, it is true. It is true. So I'll be calling it for the left side of it, that is 3. But now because we know that the values on the left side of the root has to be lesser than 5, here our maximum will become 5. Because we want all those values to be lesser than 5, right? So minimum will be minimum, but the maximum will be okay. So then what you will be doing it when you will be calling it for the right hand side. So right hand side is 6. And for the same reason, I said that the nodes on the right side has to be greater. So has to be greater than 5. So the minimum here will be 5. And the maximum here will be maximum. Okay. Similarly, you will continue to do this. You will continue to do this until you find a number. So for 3 is in between minus infinity and 5, as it is. I'll check in this function whether 3 is in between minus infinity or 5. So yes, it is in between that. So I'll be calling the function for the left hand side, like and the minimum will be changed to 3, and the right hand side. So here it will be 4, it will be minus infinity and 3. Okay. So first of all this. Now when I call for null, I'll return true. If I find a null, I simply be returning a true. So I return a true from this side. Okay, sorry. So I return a true from this side. I will be returning a true from this side. Now I will be taking a AND of both of these values, and we'll be traversing it further. So true and true is equal to true. So I'll be passing true in the top of the tree, to the top of the tree. So similarly for 4, on the left hand side I found a null. On the right hand side I have found the null. So what I can do, I'll be having a true here, I'll be having a true here. Taking end of both of these values, I get a true, and which I'll be traversing back in the tree as true. So here I receive the true from the left side, here I receive the true from the right side, and the end of these two is going to be true in itself, so I'll be traversing it back to the tree as true. So now it's time for the right hand side. So traversing back on the right hand side, again I found a null here, I found a null here, I return a true, I return a true, I return a true, taking end of both of these values, which is a true in itself, and I found a true from the left hand side, I found it on the right hand side, ultimately I will return the true, which means it is a BST. It is a BST, my dear friend. Quite simple, extremely simple approach. Okay, let me just write down the pseudocode for this one. So the pseudocode, just keep this thing in mind and you will be easily be able to write this on your own. So I'm just writing the code for this one. So now we're going to have a root. Right, this represents a node of the tree. And we're going to be having a minimum value. We're going to be having a maximum value. And initially when we will be doing it for the very first, the top root, these minimum would be representing minus infinity, and this max would be representing infinity. Okay. Then I check. What do I check, man? If the root is equal to none, I want to return a true. So I return a true. Else, my dear friend, else. Okay, it is not equal to none. So what? I'll be checking whether the root value is lesser than minimum or root value is greater than maximum. Both of these cases violates the condition for the root being the root of a subtree which is BST. So both of these conditions violates, and any of these, if any of these condition is true, you can simply return a false. Right, return a false. Otherwise, what I'll be doing, otherwise I'll be calling the same function for the left hand side and for the right hand side. But this time for the left hand side, I'll be updating the value of maximum, because left hand side values are going to be lesser than roots. So the max will be nothing but root. Okay, so I'll be calling it for the left hand side. Minimum will remain minimum, but maximum here will become the value of root. And we are taking and. Okay, so we are taking and. I'm really calling it for the right hand side, my friend. And here the minimum will be changed because you want the values to be greater. So it is going to be root value. And max will remain as it is. So it is going to be as easy as yourself. And you can simply do it. You can simply go on LeetCode and copyright this. It will work. It will work for sure. So what is the time complexity? The time complexity is of 1. This complexity we can or 1. Easier than that. And remember, my friend, I am not taking equality. I am not taken. Oh, okay. I have to take equal to error. Because even if it is equal, this condition violates. Even if it is equal, the condition violates. So I must be having equal to as well. So this is our complete code. You can try it. So that's all from my side. If I found a better solution, if you know a better solution than this, then do comment in the comment section. And if you like this video, please consider subscribing, sharing, or liking this video. It will help me really a lot. I am new to the YouTube space, and I just want to share what I know. So please help me do that. And thanks for watching this video. See you in the next video. Bye.